Hello, my name is Max and I'm a product manager at Biognosys. I used to work in metabolomics before joining the company, and so I found it especially interesting that Spectronaut, our software for DRA proteomics, can be used to analyze metabolomics DRA data as well. Let me show you how this worked out. Data-independent acquisition DRA enables simultaneous identification and quantification across a large dynamic range by providing MS2 data for all precursor ions across the entire retention time range. However, DRA data requires specialized software to deconvolute the data. We were curious to see how Spectronaut, a software that is built for proteomics, performs in a metabolomics setting. To test Spectronaut for metabolomics, we reanalyzed a dataset that was recently published by our collaborators. At first, a spectral library for 42 compounds was generated from DDA data and formatted to make it compatible with Spectronaut. The same standard mix was also spiked into human plasma samples at different concentrations, and DRA data was acquired. We analyzed the DRA data in Spectronaut using the spectral library that was made from the DDA data. As a first measure of quality, we looked at how many compounds could be quantified with a CV below 30% at different concentration levels in the dilution series. As you can see, Spectronaut performed at comparable levels to the manual MS dial-based workflow that is published in this very recent paper. This is great, but there were also opportunities for improvement specific to application of Spectronaut in metabolomics. Small molecule isomers can have indistinguishable fragmentation behavior. Spectronaut will pick the isomer peak with the highest score. This can be a problem if you want to quantify multiple isomers, or if the isomer that produces the highest scoring peak is different between files. In the case shown here, the calibration curve was not usable because of this peak picking behavior. Overall though, identification and quantification of metabolites with Spectronaut worked very well. Even though the target decoy-based false discovery rate estimation Spectronaut was not designed for metabolomics, it performed surprisingly well in practice. With that filter, we could quantify more than 30 compounds with an R-squared value of more than 0.9. Here are some examples of the well-behaved compounds in our benchmark. In conclusion, we showed that Spectronaut can be successfully applied to a metabolomics dataset. The DRA deconvolution and quantification algorithms proved to be analyte agnostic, even though some adjustments may be necessary to reach its full potential for metabolomics. Please reach out to me if you are interested in experimenting with Spectronaut on your metabolomics data. I also invite you to check out my colleagues' posters and sign up for our Spectronaut seminar series. A full list of our posters and events can be found at biognosys.com/ASMS 2020 Reboot.